Have you ever just looked up at the night sky and tried to really, truly wrap your head around how far away everything is? It's basically impossible. Well, today, we're going to try something different. We're going to shrink the entire universe down to a size we can actually walk through.
So here's the real problem. Our brains, they've just not built to handle the kind of numbers astronomers throw around. Millions, billions, trillions. After a certain point, they all just kind of blur together into this one big idea of a lot.
So let's just start with a basic question. We live here, right? But how big is our solar system actually? Like, what's the distance from one end of our cosmic neighborhood to the other?
There it is, 9 billion miles. I mean, what are you even supposed to do with a number like that? It's just a 9 with 9 zeros after it. It doesn't really connect. It doesn't feel like anything.
And that's exactly the issue, isn't it? When numbers get that astronomical, they pretty much stop being useful. So we need a better way to think about this. We need a model.
All right, so this is where it gets fun. Let's build our model. We're going to take the whole solar system and shrink it way, way down to a scale we can literally get our heads around.
And we're going to start with the biggest thing in the neighborhood, the sun. In real life, it's this colossal monster, 1.4 million kilometers across. But for our model, we're shrinking it all the way down to the size of a regular old basketball.
That's it. Simple as that. Just picture it. The gigantic, fiery center of our solar system is now something you can hold in your hands. This basketball is our starting point for everything. Now that we've got our basketball sun, imagine we just place it on the ground right here, and we're going to start walking. Let's pace out where the planets would be in this new human-sized solar system.
So, what do you think? If the sun is a basketball, the planets have got to be pretty big, right? Maybe some beach balls or marbles? Let's see.
And wow, here they are. And the first thing you realize is just how incredibly tiny and close they are. Just 10 steps away from our basketball is Mercury, and it's nothing more than a single grain of sand. Take another 8 steps, you find Venus. A few more, you're at Earth. Both of them are just the size of a peppercorn. And then another 14 paces or so, and there's Mars, which is just a tiny pinhead.
I mean, think about that for a second. In 40 quick steps, less than half a football field, we've blown past the entire inner solar system. It feels pretty crowded in here, doesn't it? But that's all about to change, drastically.
Okay, I need you to brace yourself. The next part of our walk is completely different. We're leaving this cozy little downtown area, and we're heading out into the vast, empty suburbs of the solar system.
Our destination is the king of the planets, but it is not just around the corner, not even close.
No, that is not a typo. To get from that little pinhead of Mars to our next planet, you have to walk for about 5 full city blocks. The space between them is just immense.
So you walk and you walk through block after block of absolutely nothing. And then finally, you find it. Jupiter, the giant of our solar system, is just a chestnut. That's what you get for that long, long journey.
And the walk just gets longer and lonelier from here. To find Saturn, you have to walk another 6 blocks, just to find something the size of a small plum. Then, a huge 10-block trek to find Uranus, which is now just a single peanut. And finally, a quiet, final 12-block walk to find Neptune, which has shrunk all the way down to a coffee bean.
And that's it. We've done it. Starting with our basketball sun, we've walked 1.5 miles just to pass a little coffee bean. That's our entire solar system, scaled down to a walk across town.
But this journey, it brings up an even bigger question, doesn't it? We've mapped out our little island, our whole solar system. But what about the massive ocean of emptiness that it's sitting in?
If our sun is a basketball sitting right here, where's the next one? The closest star to us, Proxima Centauri. Where would that basketball be in our model? Is it across town? Maybe in the next state over. 4,300 miles. In our little model, the next basketball, the next star, is the distance from Los Angeles to London.
So let that sink in for a moment. Our entire walk across the solar system was 1.5 miles. To get to the very next star, you would have to take that walk almost 3,000 times. That is the true scale of the emptiness between the stars.
And this is maybe the most profound thing our model really shows us. We tend to think of space as being packed with stars, but it's not. It is overwhelmingly, mind-bogglingly empty. We don't live in some crowded galaxy. We live on a tiny, precious little island in a cosmic ocean of nothing.